Electrostatics and electromagnetism.
Electrostatics and electromagnetism. So I can say, sir, what is our future? So what is actually the electronics and communication engineering base means you can say this electrostatics and electromagnetism. And this unit has got huge number of problems and different concepts we got. So first we brought in a practical manner and then we go for the explanation. So first, going for the definition of electrostatics or electromagnetism, first entire concept is based on the electrostatics. First, we'll study what is this electrostatics. Rather than the definition, we just see that in a practical manner. So every student, now animation is visible, all of you, images.
Yes, sir.
Okay. Now, every book, even in the 9th class, also you came across the word Coulombs law. Electrostatics. First, before we define that word, okay. So, what is this electrostatics means? In simple terms, imagine that every object in this world is a combination of positive charges and negative charges. So as an engineer, we should also imagine every object is practically containing the number of positive charges and number of negative charges. Sir, why I have to imagine like that? Means first let us have a look at this each image practically what's going to happen. So let me start with the second image, the balloon, blue color balloon one. So you can do this experiment in your house also. There is a water tap, water will be coming out from the water tap. Okay. Now if you see water tap position, you keep it at minimum. Imagine that small amount of water is coming out from the water tap. Now this balloon is initially rubbed with the cloth. When we are rubbing two objects, the charges from one object will be exchanged with the another object. So if you see, when the balloon is entirely rubbed with the cloth, what's going to happen? The balloon is entirely charged. Balloon is positively charged or balloon is negatively charged. So what's going to happen if you place a charged object in the presence of the water, and water is flowing means it is also charged. So water is also charged. So imagine the balloon is positively charged and water is negatively charged. So anyone tell me what happens if I am bringing positive charge and negative charge close to each other? Both will attract. Both will attract. Yes. Now you see the second image when balloon is charged with the cloth. Okay, by rubbing on the balloon structure. Now you can see what happens to the water layer. You see, water layer is attracted towards the balloon. Yes or no? You can see that one on the image.
Yes, sir.
Okay, so this is what we are supposed to prove to the world. Many experiments, many inventions based on this particular electrostatics. Sir, show me this electrostatics means according to this electrostatics theory, every object is made up of positive and negative charges. So when we rub or when two bodies are in contact with each other, there will be exchange of charges. Now every object, now you can see the water flow is negatively charged, imagine, and balloon is positively charged. You can attract the water flow, okay, in a streamline with the help of the balloon without touching, without having the contact. So what is the first figure? Now you can see the first figure. So whenever you wash any glass or any object with the water, so from the in our language, according to electrostatics, whenever an object is washed with another object, let us take the water. So what's happening? Anyone guess? There is an exchange of charged particles from the water to this particular glass. Okay, so whenever we are bringing the glass in front of the water, when water touches this particular glass, charged particles are exchanging between the water and the glass. So that is the basic thing here. Now the glass is entirely charged, this particular glass. Now let us go for the third one. You can try this one, all of you, to see. So what he is doing, he has taken one pipe, and that pipe is entirely rubbed with the cloth. Okay, and yes, it is rubbed with the cloth. With full number of times you can rub with the cloth. Okay, so what's going to happen? Again, you can see now this particular pipe is charged. Water, when it is flowing, it is already charged particle. What are charged particles? Water flowing through a pipe is the charged particle. So now you can see again small deviation in the water streamline flow, that is water flow. You can see it is there. You can see small amount of attraction. Yes or no, all of you? Very small deviation. So every body is having the positive and negative charges. So when between two bodies there is a strong force of attraction or force of repulsion will be created. Now you see what this girl is doing, the fourth image. Okay, the balloon is initially charged by rubbing with the cloth or any carbon paper. You can buy from one bookstall carbon paper, you can ask, you can buy. You can rub any material with that carbon paper, immediately that material is completely charged. Now imagine here balloon, let us say the balloon is charged with the positive, entirely positive charges, and this particular can is having the negative charge. So now what's going to happen? Positive and negative charge will attract each other. That's why, because of strong attraction force between these two objects, when balloon is moving from one place to another place, automatically the can is also is able to move in the direction of the balloon. Is it fine, all of you? The fourth animation?
Yes, sir.
Okay, right. So when a body is charged, it can attract another body, or it can make the another body to also move without touching with the ants. And now, strictly speaking, all of you, this is not the magnetic energy. So I'll show the difference between this electrostatics and magnetism. Okay, so this is what we are supposed to say. Before creation of the magnetic field, naturally electrostatics will be created. Now you can see the cat here. Okay, all these balloon structures, balloons are rubbed with the cloth, carbon paper, graphite paper. You can purchase from bookstalls, and you can rub slowly on the balloons. So what happens to the balloons? They can accumulate, they can occupy any structure, even the human body also, they can be placed on the human body. You can see here. And most important thing, sir, I want to see the electric charges. Means, let us say the climatic condition during heavy rainy season also, from the, this is called lightning. Lighting is what? Tube lights we are having. Lightning, L-I-G-H-T-N-I-N-G. Lightning. Here also you can see the last one, the person who is traveling through the car. So here also we are having the charge transmission, positive charges or negative charges. So first, sir, what I have to imagine? Okay, now I'm just going to the next slide. So first, you see all of you. Now this animation, this image, you can take the screenshot also. It is not mentioned in any textbook. Explain electrostatics. We will write the definition. Okay, electrostatics means all the students study of charges at rest, at static condition. That means what is the current? The flow of charges. So before definition of the current, what's going to happen? Which force is present? In simple words, electrostatics means we can call it as one force present between the objects. So now you see all of you in the examination also, explain electrostatics. Any definition is asked. Okay, the information which is not mentioned in the books, here is got the diagram. All of you slowly observe this diagram only. You can screenshot this diagram also. Now, what are the components we are using here? Anyone read out? Balloon and
Wall.
Ball.
Now imagine all of you, as an electronic engineer, if we see any object, we should imagine that that object is made up of equal number of positive charges and equal number of negative charges. So initially it is neutral object. So if you are bringing one particular wall, if you are bringing me one stone, I will imagine that, I should think that, and really it is happening. Every object electrostatically, it is a combination, it is having number of positive and negative charges. You can see initially the wall is having equal number of positive charges and equal number of negative charges. Okay. Now this balloon is rubbed with the silk cloth. Mainly silk cloth we use. Okay. So that is what the chemistry you are studying. Every object has got different properties. Based upon the properties, they are placed in the periodic table. Okay. So initially the balloon is rubbed with the silk cloth. Now the balloon is entirely gained with which charges? You see the balloon structure? Balloon is having highly negative charges after rubbing with the silk cloth. So balloon is negatively charged. Understanding? Now this balloon is interacting with the wall. The balloon is interacting with the wall. All of you.
Wall.
Okay, what's going to happen? You see. Now, whatever the energy the balloon is having, when two objects are in contact, they exchange the charged particles or they exchange the energy. Now you see the balloon which is having high number of negative charged particles, negative charges. Now this balloon is transferring these negative charges to the wall, which is neutral. So now you can see the second image. Negative charges are high or positive charges are high? See this there.
Negative.
Negative. So the balloon which is negatively charged initially, when it is in contact with the wall, it is exchanging its charges and the wall is also negatively charged. Okay. Now you can see here. Now similarly you can see, yes, now the balloon is negatively charged. Okay. Now what's going to happen? There is a movement of charges inside the wall. So negative means which charges are attracted? Positive charges. So whatever the positive charges of the wall is present, those positive charges are attracted towards the surface of the wall where the balloon is placed. So now you can see there is a strong attraction force will be present. Sir, I am buying one balloon and I am placing near the wall. It will not work. Balloon has to be rubbed with silk cloth for minimum 20 minutes. Slowly we have to rub and then place the balloon on the wall. It will never fall down. It will be in contact with the wall. So as the proof is nothing but when balloon is rubbed with the silk cloth, what's going to happen? The balloon is gaining the negative charged particles, and this negative charged particles, when they are in contact with the wall, all the positive charges of the wall will be attracted towards the balloon and strong electric lines of force. So remember this word. Sir, what is this word called? Electric. The combination of number of charges, positive and negative charge, is called electric lines of force or electrostatic field or electrostatic energy. Because anyone tell me charges are moving from one place to another place? No, they are just attracted and they are constant. Now you see the last one also. Here we say after this, up to this particular point, you just go through this one. So what happens next? I will define this one. Here the balloon, after certain period of time, it tries to fall, because after certain period of time again the charge concentration starts to change. So up to the 3 images, you must be in a position to give the explanation. Okay? Is it clear?
Yes, sir.
Yeah. Let me go for the next one. So I am coming practically what exactly this charge. Now we go for the definition. All of you, you can take the screenshot of this one, what I am showing. Okay. Unit 4. What is this electrostatics word? Okay, here the word spelling mistake is there, electrostatics. Okay. What is this word? The study of electric charges. So imagine every object in this world is made up of dash. All of you tell me. Every object in this world, it is having the positive charges and negative charges.
Negative.
Right. So now, as to last class also I mentioned, what happens when we eat the food? You tell me as an electronic engineer. Whenever we eat the food particles, when we chew the food particles, they are converted into smallest positive and negative charges. Sir, why I am getting the shock when I keep my hand inside the plug? Anybody you are having the answer? Because when our entire body, whenever we take the breathing, whenever we speak, and whenever we walk, our entire body is entirely charged, contains positive and negative charges. So when we keep our hand inside the plug, immediately we get the shock. So all of you, one more question. What happens to our body when we are bathing? Anyone? Whenever we are bathing, our entire body is gaining the fresh charges, positive and negative charges. So when we wake up in the morning, okay, entire body surface region has got the dead cells. So when we bath, we are going to clean all these dead cells, and once again we are going to charge our human body. So human body is also the combination of number of positive and negative charges. Study of electric charges at rest, that means they are not moving, is called electrostatics. Now all of you say this third line, read out, anyone?
Rod of glass rubbed with silk will attract small pieces of paper and is said to be
Electrically charged.
electrical.
I am taking a rod or the glass which is rubbed with silk cloth, and after a certain period of time you place small piece of paper near it. So all the small piece of paper will get attracted towards the rod or the glass. So it is called, now we say the rod is electrically charged. So what is another name of electrostatics? Electrostatics means electricity at
rest.
rest. That means rest means now you can understand the image here. You can see what is the difference between current and this electrostatics. Means in current means what? All the electrons, negative charges, electrons has to move from one place to another place. Whereas in electrostatics, we are not defining the current. In electrostatics, what are present? These charges are present. So the study of charges is nothing but electrostatics. Okay, the charge is constant. When the charge is constant, is there any energy? Yes, that energy is called the electrostatics. When the charges are moving, that energy is called the current. Now all of you have understood what exactly we are studying here. So before we pass the current through a wire, the wire is also charged. It may be positively charged or negatively charged. So this is what we say. You can take the screenshot. This is the definition. And extra point we have written. Now what is the note point, all of you? Read out, one student.
Every object is a combination of number of positive and negative charges according to the electrostatic theory.
Right. So according to this theory, if you are seeing any dead man, so he is not having any charges. The person who is live is completely filled with the positive and negative charges. So when I am taking certain sensors, those sensors will show you how many charges a body is having. Okay, so whenever we bath, whenever we take the food, whenever we are in the presence of sunlight, so our body is entirely charged in condition. Okay, so electrostatics, this word is important, is the study of forces. Sir, which force? All of you remember? Okay, I'll show you. Right, forces, electric force here between charges are described by who invented this concept? Coulombs law. Okay, I think in 9th class you have studied, no, Coulombs law?
Yes, sir.
Okay, right, but we are going in depth now. Okay, so I'm just removing this particular screen. I'll come back to this one. Okay, now, so all the students, now I'm having the charge here. So let us consider any object. Let us consider the human body. Okay, human body is completely having number of positive charges and number of negative charges. So I'm just taking one positive charge and negative charge. You must draw the diagram. This diagram also, you take the screenshot, later on you can put it on the notes. Okay, so now what is this charge? Okay, this is the positive charge, negative charge. Okay, so from the positive charge, always electric lines of force, these arrows are nothing but electric lines of force. Electric lines of force, they travel from positive charge, they move away from the positive charge, and electric lines of force, they move into the negative charge. Now what we have written? Always electric lines of force or electric field. All of you, magnetic field we have studied, yes or no? When current flows through the wire, which energy is created? All of you? All the students.
Magnetic.
When I am giving, yes. Now carefully listen. I am giving you one copper rod. Okay, you are seeing that copper rod. Ordinary person will say only rod I am seeing, but an electronic engineer should see, should experience, should visualize, should imagine that rod is completely filled of positive and negative charges. So when positive and negative charges are present, number of positive and negative charges, between the positive and negative charges, we are having certain force. That force is called electrostatic force or electric field or electric lines of force. What are the names, all of you, between positive and negative charge? Electrostatic force, electric lines of force, and or else electric field. All of you are understanding? Certain energy is present between positive and negative charges. So this diagram is very important. So if you see any object, that object is a combination of, now you tell me, any object is a combination of number of positive charges, number of negative charges, and between positive and negative charges, we are having electrostatic field or electric field or electric lines of force. Understood, all of you? So any object is given to you. It is a combination of positive and negative charges and huge amount of electric lines of force. These are not magnetic lines of force. These are electric lines of force. Now, when current flows through the object, we create magnetic energy. So every object, whenever current is flowing, it is a combination of how many fields? Tell me, all of you. First class introduction I mentioned. Anyone tell me? Every object, whenever current flows through the every object, it is a combination of electric field and magnetic field. Remember anyone? Introduction class I mentioned. Sir, what is ECE? ECE, we generate electric energy and magnetic energy. Yes or no? You remember or not? Okay.
Yes, sir.
So electronic engineers, they generate electric energy or electric field and magnetic energy or magnetic field. These electric and magnetic fields are not constant, they are perpendicular. They travel from one place to another place, and because of that electric and magnetic field only our cell phones are working, and we are sending the signals to the satellites. So everyone, so what is our explanation today's class? First, if an object is given to you, that object is a combination of number of positive and negative charges. Between positive and negative charge, each positive and each negative charge, huge number of electric lines of force are present, which is called electrostatic field or simply electric field. Okay, now you see, all of you. Examples I'll show you first. Okay, let me play this one. Now all of you, let me come from this one, the last image. So imagine you are wearing the sweater or else one coat from morning to evening. So you will feel the sensation of certain suffocation or the heat also. So why heat is generated? Because there is an exchange of positive and negative charges between the shirt and the sweater. Here also, the girl is having the balloon on her head. Okay, so what's going to happen? The balloon is entirely charged. Okay, now, so you can try this one, this comb. Okay, it is attracting what? Small pieces of paper. Now you can read, anyone read what it is mentioned here?
A charged comb picking up small pieces of paper.
Due to static electricity. Okay, the electricity as rest is called the static electricity or electrostatics. So all of you, so what you have to do, you just apply the oil to your hair and just use the comb. Then immediately the comb is charged. Now this comb is able to attract small piece of the white papers. This is not animation, this is done in real. So here also you can see this person, let us say this is the mirror. The mirror is having entirely the combination of positive and negative charges. So when we move towards the mirror, what's going to happen? All the negative charges are arranged at the surface area of the mirror here. You can see the person. So here also one object. Now this is very important. A neutral object. Anyone tell me what is neutral object? Just see the animation first. Neutral object means what? Anyone? See the animation and tell me.
Same number of positive ions and negative ions is
Ions or charges. Okay. A neutral object contains equal number of positive and negative charges. But when this neutral object is brought very close to any charged object, Depending upon the object, what's going to happen? So this green color object is nothing but the entirely completely positively charged. So what happens to this negatively neutral object? All the negative ions or negative charges are attracted towards this particular object. Okay, so we say inside any object there are the charges. So you see, all of you, this one, conduction, this process is called conduction. All of you, what do you mean by the word induction? Anyone tell me? You have done self induction, mutual induction. Whenever magnetic energy is present between two objects, then we use the word induction. Whenever electric field is present between two objects, or electrostatic field, or positive and negative charges, then we use the word called conduction. Understanding, all of you? Now you see here, what is explanation? A iron rod which is entirely negatively charged, it is brought and it is in contact with one circular ball or else iron ball. Now you can see iron ball is completely filled with negative charges. You see the animation here? So we say becomes negatively charged. Electrons transfer to the order making same charge. Understood? This is what we say. So when we touch any other person also, that person is entirely charged. We cannot experience that particular thing practically, but with sensors only we can imagine, we can obtain the values. So first definition we have taken, electrostatics. So all students, this introduction, if it is okay, now we are going for the next one. First topic is nothing but Coulombs law we are going to discuss. Okay, Coulombs law. All of you see here. Come on, new slide is visible now, all of you? New image.
Yes, sir.
Okay.
Yes, sir.
Now you can have the screenshot of this one. Okay. I brought it in small, very small, in a simple manner. Okay. Now all students, attraction force, repulsive force, two charges. Now how to explain in the examination? Okay, you sir, you are saying electrostatics, electric field is present everywhere. How to explain? So what Coulombs has brought, they have done, there is a force of attraction between two charges. So now, what is the first line? Read out, anyone? First line.
Let us consider two charges Q1 and Q2.
Yes, two charges Q1 and Q2.
Two charges Q1 and Q2 which are separated by distance R.
Distance R. All of you, you must draw the diagram. Better you draw the diagram now only. Okay, in the notes. Or else you take the screenshot after the class, you can draw. So Q1, let us consider Q1 and Q2 are two different charges. Now tell me, a glass is made up of how many charges? We cannot say how many charges. So a glass is having, let us say, 500 number of charges. Okay, glass contains. So I cannot draw every time 500 number of charges. So I am just taking, in order to explain, in order to prove that, in order to calculate how much force is present between these two objects. That means one object is making other object to attract. So we say, let us consider two charges. So an object contains n number of charges, Q1 and Q2, which are separated by distance. First you have to draw the diagram. Is it clear, all of you? Okay, now diagram is drawn. So no need to draw this diagram, all of you. This diagram, if you have drawn this one, that's okay. So according to Coulombs law, now Coulombs law, what it is saying, okay, one object is attracting another object. Okay, okay, that's okay. So what they have mentioned? Coulombs law states that electrostatic force, yes, electrostatic, one second. Electrostatic force between two charges is directly proportional to product of charges. F is directly proportional to Q1 into Q2 and inversely proportional to the square of the distance between the charges. So as you can see here, the charges, when they are coming closer to each other, what's going to happen? Attraction force, the force is maximum. When the charges are moving away from each other, the force starts to decrease. So you can see, yes, you can see the animation now. When the charges are coming close to each other, the force is maximum. And when they are moving away, the force is minimum. So you are supposed to write this one. F is directly proportional to Q1, Q2, and F is inversely proportional to the square of the distance. So F is equal to certain constant. This constant is called constant of proportionality, permittivity. All of you, what is this? K is equal to K. I will tell you the constant. Yeah, K is one constant And what is this value? I'll show you later on. But up to this one, I hope everybody can write. Explain Coulomb's law means what? Let us consider two charges which are separated by certain distance. According to Coulomb's law, the electrostatic force or force is directly proportional to the product of two charges and inversely proportional to the square of the distance between them. Okay, so what is that force? Because of that force only balloon is attracted towards the wall. So now let me share the continuation of this one. Okay, all of you. Now you see, new screen is visible now, all of you. New screen.
Yes, sir.
Yes, sir.
Yes,
So,
sir.
yes. All students, Coulomb's law means Coulomb's, they have explained if you are having two charges, between two charges, certain force is present, electrostatic force. So, what is the formula for that Coulomb's law? All of you, force F is equal to K Q1 Q2 by R square. All of you, anyone repeat what is that formula? All of you, force between two charges, F is equal to K Q1 Q2 by R square. Okay. Now, this K is explaining what is the amount of force. Now, anyone read out this value, remember this value. There is no proof for you people as you are in Polytechnic. Electric force that acts between two bodies is equal to the product of two charges. Okay. But here you read out this value, how much here? 9 into 10 power 9. Visible all of you?
Yes, sir.
Okay, so you must remember this value. As you are in diploma, no need to prove this one, but I'll show you the proof also. So what is the strength? What is the value? How much force is present between the balloon and the ball? Now you tell me, all of you, just tell me the value. 9 into 10 power
10
9.
to the power of 9.
So these units we will see later on. I think in physics, you are studying units and dimensions, right? It is done.
Yes, sir.
Yes, sir.
Units and dimensions. Okay, that's so. What is the force between two objects? Means 9 into 10 power 9. Okay. Now this material also will be given to you. So same explanation in detail it is kept here. So now Coulomb's law you see Q1 Q2 by D. We have taken R square and we got certain K. Okay. Now you see all of you, all students. Now you concentrate on this diagram. Sir, what is this word? Anyone read out what is this word? Permittivity. Permittivity. Okay, spell anyone?
Permittivity.
Sir, what is permittivity? Now listen, I have written the explanation already. You can screenshot or you can take that one. 1 second. So that definition is very simple. Permittivity in general terms. Okay, now you can take screenshot. I want any one student to read out slowly.
The
ability of a
The
material to
ability
allow
of the material to
electric
allow
lines of
electric
force
Yes,
to pass
through it. See,
through it
let
is
us say,
called electric permeability.
okay, let us say I'm giving you one pipe and that pipe is allowing maximum water to flow through it. Then I will say it is certain, okay, it is allowing the water. So I'm giving you one particular object. If that object, how much amount of electric lines of force? Electric lines of force, just now we have seen between positive and negative charges or electric field. Ability of a material to allow electric lines of force or electrostatic field through pass through it is called the electric permittivity. That means, okay, now screenshot the definition. Ability of a material to allow electric lines of force to pass through it is called permittivity or electric permittivity. Sir, what is the meaning of this definition? Means now all of you, now you see two charges are separated by certain distance. Let us say two charges are separated by distance inside one river, that means inside the water. Then permittivity will be different. And two charges are separated inside one iron rod, then permittivity is different. So permittivity is the medium through which two charges are separated. So initially, now here we say permittivity is nothing but if I am using the air, between the air. So air is nothing but the permittivity. Okay. Now we'll read here certain value, then you will understand. Now anyone read out here? Permittivity of water. What is the value?
80.
80. The scientists, they have fixed certain values for each object. Permittivity of water is 80. That means we say if two charges are displaced by certain distance in water, then permittivity is 80. That is, it is not allowing maximum electric lines of force. That water is not allowing maximum lines of force. Now you see, related to permittivity of air. Permittivity of air is how much? 1.0006. Therefore, it is almost equal to 1. So it should be 1. If it is 1, then we can say maximum electric charges can exchange their energy. So here in this diagram, sir, what is this permittivity? Means two charges are separated. They can be separated in a iron rod, or they can be separated in a water or in the air. So here the meaning is nothing but the permittivity. The symbol is nothing but, all of you, symbol is what they have written. This is called epsilon. 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 Epsilon E. Similar symbol. E naught and ER. So I'll tell you what is E naught also. Okay. E naught and ER, the symbols. So all of you, force is directly proportional to Q1, Q2, inversely proportional to R square or D square, where this is what, all of you, this is the symbol of the epsilon. Permittivity of the medium, air, water or iron rod. Okay. So what is that formula, extended formula, all of you? We are writing F is equal to Q1, Q2 by R square, or F equal to Q1, Q2 by D square. But here we say permittivity, absolute vacuum. Okay, these values we'll discuss next class. So remember, permittivity of air is nothing but 1, and permittivity of the vacuum or any object we are taking. What is the value here? 8.85 into 10 power minus 12. So if you substitute all these values in this expression, what is the expression we are having? Q1, Q2 by 4 pi. So K is nothing but taken as if 4 pi epsilon naught into D square. If you substitute all the values, finally what you are going to get, we'll see in the next class this derivation. Finally what you are going to get, anyone read out this one? 9
into 10 to the power of 9.
Yes. So how many forces it is explaining between two charges? Define Coulombs law. How many forces? Read out: gravitational, magnetic and electric forces. So we are having electric forces. You must remember this one. Okay, we continue in the next class. So imagine the basics of this particular class, today's class. Okay, Coulombs law is 1 3 to 4 line derivation. Problems we are supposed to do. So F is equal to Q1 Q2 by this 4 pi. We have to remember the formula and then we use this particular explanation. Any question, anyone? No need to worry for the material. What are the material I will release as on date? You are supposed to prepare that.
Okay.
Okay.
Okay, sir.
Okay, sir. Thanks.
Okay.